All right, today we're going to dive into a really powerful idea. It's a tool that helps us see the hidden story inside a bunch of numbers, the secret consistency, or, the total chaos. And trust me, it goes way, way beyond a simple average.
Okay, let's start with a little puzzle. Imagine you've got two marathon runners, and over their last few races, their average finish time is identical. I mean, exactly the same. So you have to put money on one of them for the next race. Who do you pick? Right? The average, on its own, just doesn't give you the full picture. It's not enough to make a smart bet. And here's where the plot thickens. So you look at runner A, and wow, they are rock solid, super consistent, always hovering right around that 3-hour mark. But then you look at runner B, and they're all over the place. One race is crazy fast, but the next one is way, way slower. They both average out to 3 hours, sure, but the stories of how they got there couldn't be more different.
So here's the key takeaway. The average, it gives you the middle ground, right? The center point. But it tells you absolutely nothing about how spread out all the numbers are. To figure out who's more reliable, who's more consistent, we need something else. We need a better tool. And that tool is called standard deviation. Seriously, you could just think of it as a consistency score. This is the magic number that's going to solve our runner puzzle. It's what lets us finally see the real story that the average was hiding from us.
So what is this thing exactly? Well, at its core, it's just a single number that measures how spread out your data is. Basically, it tells you, on average, how far each individual number, whether that's a race time, a stock price, or the temperature outside, is from the group's overall average. It's a measure of distance from the center.
Okay, so think of it like this. If you have a low standard deviation, it means all your data points are tightly clustered together right around the average. That signals high consistency, high predictability. That is our runner A, for sure. On the other hand, a high standard deviation. That means your data is scattered all over the map. That's low consistency, tons of variability. And that's our runner B.
Now, this whole idea isn't just for marathon runners, not at all. Once you get the hang of standard deviation, I promise you'll start seeing it everywhere. It shows up in so many different parts of life. Let's take a look at a few real-world examples.
Okay, so take finance. Standard deviation is basically a measure of risk for a stock. A really high standard deviation means the returns are volatile, they're unpredictable. Or think about weather. A coastal city, say San Francisco, has a really low standard deviation for temperature. It's pretty much the same year-round. But an inland city, like St. Louis, huge swings, high standard deviation. Even in business, a store in a mall probably has steady sales, low SD, while a seasonal beach shop, its sales are going to be all over the place, super high SD. See, it all comes back to predictability.
All right, so how do we actually calculate this magic number? Let's take a quick look under the hood. And don't worry, this is going to be totally painless. We're not here to memorize formulas, we just want to understand the logic behind it all. So to walk through this, let's use a sample set of just 6 scores. We've got 46, 69, 32, 60, 52, and 41. Right now, it just looks like a random jumble of numbers. But we're about to uncover the hidden pattern inside.
Okay, here we go, step by step. First, you find the average of all the scores. For our numbers, that's 50. Easy enough. Next, you figure out how far each individual score is from that average of 50. Some will be a little below, so you get a negative number, and some will be above. Now, step 3 is the clever part. We need to get rid of those negative signs so they don't all cancel each other out. So what do? We square every single one of those differences. Poof, now they're all positive. Step 4, we just add up all those squared numbers. Then, for step 5, we find the average of that new list, which gives us something called the variance. And finally, the grand finale, step 6. You take the square root of that variance. That brings the number back to the right scale, and that is your standard deviation.
And there you have it. The standard deviation for this set of numbers is 13.31. So what does that actually mean? It means that on average, each score in our little group is about 13.3 points away from the middle score of 50. That number, 13.31, is our measure of spread. It's how we quantify the consistency.
Okay, so far we've been talking about describing data, but this is where standard deviation gets even cooler. It goes from just describing what happened to actually predicting what's likely to happen. And this leap happens when we pair it with one of the most famous shapes in all of science and nature, the bell curve. This is what's officially called the normal distribution, but pretty much everyone knows it as the bell curve. And it's just this elegant, symmetrical shape where most of your results are clumped right there in the middle, around the average, and then it smoothly tapers off on either side.
But here's the truly amazing part. That entire curve, where it's centered and how wide or skinny it is defined by only two numbers, the mean and, you guessed it, the standard deviation.
And listen, this shape isn't just some weird, abstract math thing. It shows up everywhere in the real world. Think about the heights of thousands of people, or scores on a big standardized test, or even blood pressure measurements across a population. All these things, even tiny errors in scientific experiments, they all tend to naturally fall into this predictable, bell-shaped pattern.
And because this bell curve pattern is so incredibly common, it gives us a super powerful, really simple rule of thumb we can use to make predictions. It's sometimes called the empirical rule, but most people just know it by its numbers, the 68, 95, 99.7 rule.
Let's break that down. It's actually really simple. The first number, 68. This means that for any data that fits that bell curve shape, about 68% of everything, all the data points, will fall within one standard deviation of the average. So that's the big chunk right in the middle.
Okay, now let's widen the net a bit. If we go out 2 standard deviations from the average on both sides, we now capture about 95% of all the data. I mean, that's pretty much everybody. This is the range where the vast majority of results will land.
And what if we go out one more step, to 3 standard deviations? Well, at that point, you've captured 99.7% of all the data. That is basically everything. Anything that falls outside of that range is a true rarity, a real outlier.
Okay, let's make this super concrete with an example. Let's say we have a memory test. The average score is 50 and the standard deviation is 10. Now, if we use our new rule, we know that about 95% of people will score within 2 standard deviations of that average. So what's that? Well, 2 times our standard deviation of 10 is 20 points. So we can confidently predict that about 95% of everyone who takes that test will score somewhere between 30 and 70. Just like that, we have a really solid, predictable range.
And really, that's the big idea here. The average tells you the center of the story, but the standard deviation tells you the rest of the story. It tells you about the spread. It gives the average context. It helps you understand variability. It helps you manage risk, and it gives you a powerful way to know what's normal and what's truly out of the ordinary. It lets you know what to expect.
So, I'll leave you with a question to chew on. Now that you have this new lens for looking at the world, this tool for understanding consistency and spread, what's something in your own life, maybe it's your daily commute or your monthly spending, what's something that's actually way more predictable than you ever realized?